Morning, this is your stats sensei, Mr. Spensei, and this is the exit ticket comparing the normal distribution to central limit theorem. So suppose the mean in room and board expense per year at a certain four-year college is 7,850. I'm going to note that down, 7,850. You randomly select 9 dorms. All right, so N is 9, offering room and board near the college. Assume that the room and board expenses are normally distributed. That's important because our sample size is small. It's not large enough to be normal by central limit theorem, but it's already normal, so we're good to go. And it has a standard deviation of 1125. All right, our first question, what is the probability that A is 1? Whenever it's 1, we're looking at a norm CDF. So I'm going to go ahead and write that down as a norm CDF. Has room and board of less than 8,180. Well, my picture is this. We have a mean of 7,850. 8,180 is above it, so I need to be above it, but it says less than, so I'm shading this way. So we want the probability that X is less than 8,180. Well, this is a norm CDF, and please remember it goes to negative infinity. Negative infinity. We stop shading at 8,180. We have a mean of 7,850, and we have a standard deviation of 1,125. We don't even need our sample size for this problem. Lower, upper, mean, standard deviation, right? Always get your labels in there. So here we go. Second vars, normal, CDF, lower, -9 raised to the 99th, upper, 8180, mean, 7850, standard deviation, 1125. We end up getting about 61%, and it makes sense because we shaded over halfway. So our probability is about 0.6153. All right. What is the probability that the mean room and board of 9 dorms is less than 8,180? All right, so they're asking for the X bar. That tells me I need to use the Z formula. We have our population is mean is 7,850. Our standard deviation is for our population is 1125. Our sample size is 9. We're drawing a picture, and 7,850, 8,180, but this is no longer an X. That was an X up here, but here it's the X bar. We're shading this way, and we're going to have Z equals X bar minus mu, standard deviation of the population divided by the square root of n. And our probability statement is the probability that X bar is less than 8,180. When I plug in, I'm going to have the probability that Z is less than 8,180 minus 7,850 divided by 1,125 divided by the square root of 9. Stat test, Z test, mean 7850, standard deviation 81, not, excuse me, 1125. X bar, the sample mean, 8,180. 8,180. And our sample size was 9. And we said less than, make sure I have the less than arrow highlighted. And I get the probability, and so I end up getting equals the probability that Z is less than 0.88 equals 0.8105. All right, so there's about an 81% chance that we'd get a value like that. All right. What is the probability the mean cost of a sample of 4 dorms is more than 7,250? Once again, what was our population? Our population had a mean of 7,850. It had a standard deviation of 1125. And this time we're talking about 4. And it says mean, so I know I'm using the X bar, so I need to use the X bar formula. So Z equals X bar minus mu sigma divided by the square root of n. And we're looking for the probability that X bar is greater than 7,250. I'm drawing a picture of this. Mean of 7,850. And we're somewhere down below it, which means we should end up with a probability greater than 50%. All right, and we're looking for that probability, and this is an X bar. So we want the probability that Z is greater than 7,250 minus 7,850 over 1125 divided by 4. That test, Z test, 7,850, 1125, and we want 7250. Changing our sample size to 4, and we want it greater than. And we get the probability that Z is greater than a negative 1.0666. Z score equals 0.8569. All right, appreciate you for watching and hope to see you on the next one. Thank you.